Assalamu alaikum. Today we are going to discuss chi-square test that was developed by Carl Pearson. Pearson is the same person who has developed the statistics for correlations. So chi-square test is also a kind of test for association, but not for the continuous data, rather for the nominal data in particular. And that was the formula which he produced for computing the chi-square statistics for basically two purposes. One was the test of independence or test of dependence, and the second was test of goodness of fit. Test of independence or dependence means that chi-square statistics is used to test whether two nominal variables they are associated or not, or they are independent of each other or not. So test of independence is the widely used purpose of chi-square test when the attributes or the variables used for this purpose are measured on the nominal level. And by nominal level we mean like yes and no and true and false, or subject 1, subject 2, subject 3. So these are the values which are not connected together, and there is no significant or remarkable relationship of order or ranking. They simply represent unique values, like yes means yes and no means no, and these two values cannot be compared or computed together. In this lecture we shall talk about test of independence or chi-square, as it plays a role to test whether or not two nominal variables they are dependent on each other or they are associated with each other or not. So chi-square test is used for testing independence and second, goodness of fit. The test of independence determines whether two or more observations across two populations or two variables are dependent on each other, whether one variable helps to estimate the other, or whether one variable helps in predicting the value of the other variable. And second popular use of chi-square test is testing for goodness of fit, which determines whether an observed frequency distribution matches a theoretical frequency like normal distributions and binomial distribution and Poisson distributions. These are the distributions which have been developed by statisticians as showing different types of facts and figures. So all the statistical tools and techniques are developed with reference to normal, binomial and Poisson distributions. So the researchers are supposed to come up with such data which matches with one of these distributions, so that the related statistics can be used to answer the research questions. In this lecture, as I have said before, we shall discuss test of independence and use the chi-square to compute the statistics which helps us in computing the level of association or independence between two nominal variables. Chi-square tests whether two nominal variables are dependent on each other. For example, one of the hypotheses can be that variable 1 and variable 2 are associated. Variable 1 includes yes and no categories, while the variable 2 is the gender variable with two categories of male and female. Likewise, another example that H2 can be that variable 1, domicile, which has two categories of local and non-local, predicts variable 2, that is the use of social media, with two categories of yes and no. you can see that yes and no, male and female, all are local and non-local are the nominal variables, and they have one attribute for statistical manipulation, and that is uniqueness. If calculated value, that is the condition which we will use to decide whether there is association or not. In chi-square, the chi-square statistics is computed, which if calculated value is greater than the table value of the chi-square distribution, the null is rejected because it means that two variables are associated. It means that the statistics which will be computed on the basis of observed data or the data in our data matrix, if the computed value of statistics or chi-square is greater than the chi-square statistics given in the chi-square distribution table, which is available in the books and online as well. If the computed value is greater than the table value, then it means there is association and there is no independence, and null hypothesis of that there is no dependence is rejected and alternate hypothesis will be accepted. But if the calculated value is less than the table value at certain level of significance for given degrees of freedom, we will discuss this afterwards, it is calculated that the null is accepted, meaning that two attributes are independent or not associated. Degree of freedom means the value which we shall use to locate the table value related to our computed value. First, I have computed chi-square in Excel. Here is the observed frequencies table, which is a simple cross tabulation of the variable domicile with two attributes of local and rural, and the other variable is with yes and no. So this is simple cross tabulation of the observed data. Then we have used this formula, row total multiplied by column total. Row total is 87. To compute chi-square statistics, we shall use two examples. Example 1 will be used through Excel, and then we shall move to the SPSS for computing chi-square statistics. In Excel, I computed all the steps required to reach the chi-square statistic at the end. First table, that is observed frequencies, includes the cross tabulation of the variable 1 and the variable 2. Variable 1 domiciled with subcategories of local and rural, and the second variable was with two categories of yes and no. So simple cross tabulation, which simply says that 54 number shows that 54 local members have given yes, and 35 rural members of the sample they have given yes. Likewise, in second column, 33 shows that no given by local members, and 41 are the rural members saying no to the research question. So observed frequencies which come out of our questionnaire are then used to compute the expected frequencies. Expected frequency means statistically that if there was no association, then what should be the frequency in this column and that column and in these two columns. Expected frequencies are computed using a simple formula, and that is row total like this 87 and column total like this 89 and 74 So there are two row totals 87 and 76 multiplied by each other and then divided by grand total, and that is 163. That is the n is the 163 are the sample size. So using this formula we have first computed the expected frequency of 54, where the formula used was 87 multiplied by 89 divided by 163, and it gives the results of 47.5. Likewise, all the four expected values are expected frequencies of the four cells was computed. After that, the third step, that was the first step and that is the second step. Then in the third step we have to compute the chi-square statistic using this formula. Chi-square is equal to summation O minus E square divided by E. So we have to prepare 3 columns showing the computations related to O minus E. O minus E means 54 minus 47.5 and the result is 6.50. So simple O minus E. Then this O minus E is squared in this column, and finally these squared values of O minus E are divided by E, and then these all four values are summed up into the chi-square statistic, that is 4.20. Now to check whether our computed value, that is 4.20, is greater or less than the table value. Here I have pasted a copy from the net which gives probability level alpha, or it is in other words chi-square distribution, frequency distribution, with computing the degree of freedom from our own data. Degree of freedom is computed as number of columns minus 1 multiplied by number of rows minus 1. Here there are 2 columns and 2 rows. So 2 minus 1 multiplied by 2 minus 1 is equal to 1. So at this level, 1 degree of freedom, we have to use 0.05 p-value or alpha value or significance value and check that the table value given with 1 degree of freedom and significance level of 0.05, it is 3.84. 3.84 is obviously less than 4.20. So the computed chi-square statistic in this example is greater than the table value. Therefore, computed value is greater than the table value. Therefore, there is association between variable 1 and variable 2. Null hypothesis is rejected and alternative is accepted. Another example or example 2 for the same thing will be that we shall compute chi-square statistics in SPSS. To compute statistics, let's first get some background knowledge about this example. Here we shall use 141 students as the sample. Nominal variables are 2. Variable 1 is daily use of social media with 2 categories of yes, no, and variable 2 is again gender, male and female, the same formula. And here we can create some questions, and all these questions actually refer to the same thing: whether variable 1 and variable 2 are associated, or whether variable 2 predicts variable 1, or whether variable 1 and variable 2 are independent of each other. So all these refer to the same thing, and that is whether 2 variables have some association, some interaction, some relationship. So the test of independence, as we have said before, is the search for any dependence between the two variables. To compute the chi-square statistics, we will use this data matrix, which has about 141 members in the sample, and we will use gender and the question daily use of social media, which has two categories of answers, yes, yes and no. Let's go to analyze descriptive statistics, and this drop down window gives us more options, and we have to select cross tabs. Now we have to place one variable, one of these two variables in rows and the other in the columns, as we do for cross tabulation. And as per researchers and statisticians, it doesn't matter which variable is placed in rows or columns. However, some statisticians believe that rows should include the x variable and the columns must contain the y variable. In this case, for example, we can understand that it is not the daily use of social media which is going to affect gender, rather we can expect the otherwise. So gender will go in row as x variable, and daily use of social media and daily use of social media will go into columns as the dependent variable, onto which we are looking for some effect of gender. In statistics, we shall check the chi-square and phi and Kramer's V. This is the test of significance, which will give statistics about how far the model and the results computed are significant and acceptable or valid. And continue. Then in cells, observed frequencies are already checked. We will add the expected frequencies and continue and press OK. So here are the results. Case processing summary, leave it. The important table is second one. It contains all the observed as well as expected frequencies computed by the SPSS, and we can see that the observed, for example, in first column of yes and male members, they are giving 46 members are giving yes. However, the expected frequency is 38. There is big difference, and as we have said before, expected frequency is actually the computation of the frequency in this column without the association. Without computing the association, the expected frequency is said to be 38 while the observed is 46, so there is big gap. The next table is about the chi-square test or chi-square statistics. Pearson chi-square, the value is 6.275 with 1 degree of freedom, and here you can see the significance is 0.012, which is far less than 0.05. And finally there is the table of Kramer's E significance level it is showing. So we shall discuss this in the slideshow. I have taken all these results over there for visibility and discussion in a different environment. So let's go back to the slideshow. So we are back from SPSS. Here are the results we have computed over there. This is the first table is about the observed and the expected frequencies, the same table. Second, chi-square tests, and we said that the chi-square computed or calculated chi-square statistic is 6.275, and it is also significant because the significance required is 0.05 and 0.012 is far less than the minimum limit. Further, the Kramer's V, the significance test, or the test showing the effect of the one variable on the other, it is interpreted as per this required values for determining the effect, that if the value is 0 then there is no effect, but the value from 1 to 2 shows the low effect or lower level of effect. If this Kramer V is between 2 and 3, it means medium effect, and if it is greater than, it is 3 and greater than 3, then it is taken as high effect. So in this case the value is 0.21, which means that the effect created in this data matrix or in this test of two nominal variables is medium. So it can also be verified that the value of chi-square is 6.275, computed value is 6.2.5, while the table value of the same is with 1 degree of freedom, it is 3.841, as we have discussed in the previous example. So 6.275 is far greater than 3.841. It confirms that there is huge evidence of association between the two variables. To conclude our discussion, it can be said that in this lecture we have used chi-square as a test of independence or dependence of two nominal variables on each other. We have used gender as predictor, x variable, and yes/no answers as y or test variables. Test of independence actually means checking independence, or test of independence actually means checking dependence of two variables. Chi-square test statistics can be computed in Excel worksheet or SPSS. Learners must begin with Excel to understand the process and then use SPSS when publishing their results as per instructions of Higher Education Commission. So that was all about chi-square test as the test of independence. As I have said before, next video will be the use of chi-square as the test for goodness of fitness. So thanks for listening and watching the video. See you in the next video. Khuda Hafiz.